go. So what we're starting today and what we'll essentially finish up the rest of the chapter with is solving quadratic functions. Now we're going to go over many different ways to solve quadratic functions. Some work better than others, and we'll see that as we process through it. So the rest of the chapter is really going to be dealing with solving. So what we're going to be covering in 3.3 is really solving quadratic equations by graphing algebraically, and we may or may not delve into some kind of real life problems, kind of how we can see them in the real world, quote unquote, the real world. Now, solving a quadratic equation in one variable, is an equation that can be written in the standard form ax squared plus bx plus c, where a, b, and c are real numbers. Where a, b, and c are going to be real numbers. They could be positive, negative, fractions, decimals, as long as a is not 0. A cannot be 0. Because if a is 0, well, that means ax squared would be 0. We wouldn't have a value there, which means it wouldn't be a quadratic equation. Equation is considered to be quadratic if we do have a variable x squared. If we have a variable to the second power, then it is quadratic. Without that, it would not be a quadratic equation. Now, a root of the equation is solution of the equation. And we can do this in various methods. Or really, we're trying to find out what value of x will make the function equal 0. We're trying to find out what value of x will make the function equal 0. Now, the first way we can do it is by graphing. Find the x-intercept of the related function. Because the x-intercept, the y value is 0. Because any x-intercept will come in the form of x comma 0. Because where it crosses the x-axis, the y value is 0. So the x-intercepts will be the value of x that makes the function equal 0. So if I can find the x-intercepts, I can find the solution. That x value will be the solution. We'll also look at the square root method, and we've already done factoring. Because when we factor it, we set it up as 2 sets of parentheses equals 0. Because whenever I have 2 or more things multiply together to equal 0, one of them has to be 0. So, the first method we're going to look at is solving these functions by graphing. Now, the way that we can solve this by graphing is first off finding the vertex. Because if we can find the lowest point on the graph and then go out to the left and right to see where is it going to equal 0. But won't also the graphing calculator graph the function for us? Well, yeah, so why don't we use that? And we do want to make sure the function does equal 0. So here our function is x squared minus x minus 6 equals 0. So it is equal to 0. So what we can do is we can pull the graphing calculator up and hit y equals. Now, if there's already a function typed in, we can clear it out by hitting clear. And we want to type that function in. We want to type in x squared minus x minus 6. Well, to type it in, we can hit, clear this. We can type in x squared minus x minus 6. Once you get it typed in, go on and hit graph. Up there at the very top. So our graph button up here will graph it for us. So we have 2 places where it crosses the x-axis, yes? So those will be our solutions. So what is the x value, or what is the x value at the spots where it crosses? Can we see that? -2, 0, and at 3, 0 is where it looks like, yes? Well, if we want to make certain, we can go second graph. Second graph will pull up a table. We have the x and y values. So if I look at -2, well, it tells me what? -2, 0. When x is -2, the y value is 0. But that's what a table is. It gives us the x value and its corresponding y value. Question? Because we can go up and down on the table. Cursor up and down. And we also have the point 3, 0. Because when x is 3, the y value is 0. And again, what are we looking for? We're looking for what values of x make the function equal 0. We're wanting to know where y is 0. Does it really matter where x is 0? No, because that just gives us the y-intercept. Because for the solutions of these functions, we want to know the x-intercepts, where y is 0. So that means I can come back over here, and we can really say that the solution is x is equal to -2 and x is equal to 3, because the two spots where the y value was 0, the x values were -2 and 3. Now, if we wanted to check it to make sure we got the right values, we can go on and plug it back into the function. So I can plug -2 in for x and see, does this equal 0? Well, -2 squared is +4. Negative and a -2 would be +2 minus 6. Well, 4 plus 2 is 6, and 6 minus 6 is 0. So it does show us that if we plug -2 back in, we would get 0. We can do the exact same thing with 3. We can say 3 squared minus 3 minus 6. Well, 3 squared is 9 minus 3 minus 6. -3 minus 6 would be -9, and 9 minus 9 is 0. So both of those values, if we plug them back in, do give us 0. So the solutions, or the roots, for the quadratic equation x squared minus x minus 6 equals 0 is -2 and 3, because those two values of x give us 0 for this function. Any other questions on this here? Okay. Let's look at the next one. Solve the equation by graphing. So we have -2x squared minus 2 equals 4x. What's different about this equation? It's not equal to 0. Because when we dealt with factoring or solving quadratic equations by factoring, we had to have it equal 0. So even with graphing, we still need this to equal 0. Yes, we can subtract 4x from both sides. And if we subtract 4x from both sides, well, 2x squared and 4x are not like terms. 4x and 2 are not like terms. So we just have 2x squared minus 4x minus 2 is equal to 0. And I always try to rewrite it in standard form. Biggest variable with an exponent goes first, so x squared would go first, then x, and then the number without x. We want it to go in decreasing power. Now, when we were factoring this to solve, well, we would have divided by 1 or pulled out a greatest common factor. Yes? Does the calculator really care that the term in front of x squared is negative? No, it really doesn't care if there's a greatest common factor or the numbers are negative. What we can do is we can just take this function here and plug it in. So when we want to plug it in, we would go over to y equals. We can clear this out because that'll be a little bit easier to work with. And we can just type it in. So -2x squared minus 4x minus 2. Now in front of whatever the first term is, if it's negative, we're going to use the negative sign. Any other ones after that, we need the minus sign to show subtraction. If you try to put a minus sign in front of the 2x squared and there's nothing in front of it, it'll say an error, it'll throw up an error. It wants a negative there, but we need subtraction everywhere else. Once we get it typed in, what do we hit? Graph. So where does it cross the x-axis? Does it cross it? No. But it looks like it might touch it there. It might touch the graph at that point. Well, let's go second table to make sure, because we can always scroll up and down, but at -1, the y value is 0. Now, I'm going to go back to the graph so we can look at this. This here, this point, x equals -1, what we will call this, and we'll see this more in chapter 4 when we look at higher degree polynomials, is said to have an even multiplicity. Anytime the graph touches the x-axis but does not cross it, it's considered to have an even multiplicity. That means there's an even number of zeros at that point, or an even number of solutions at that point. So here, every quadratic is going to have 2 solutions. So I know one of the solutions is x is equal to -1. What do we think the other one's going to be? X is equal to what? Yeah, -1. So the solution for this here is we could say that x is equal to -1 and x is equal to -1. We don't have to list it out twice. We can just list it once. But every quadratic will have 2 solutions. They may not be unique solutions, that they're both different. Because we could have that x is equal to -1 and x is equal to -1. There's 2 at that location. But there's still going to be 2 solutions. They're just the same value. Questions on this here? Are you ready for the next one? X squared plus 8x plus 12. Well, it's already equal to 0, yes? And we want to solve it by graphing. Well, we can go on and plug it into the graphing calculator so we can hit y equals. Go x squared minus 8x plus 12. We can go on and type it in and hit graph. Now, we could go straight to second graph and look at the table, but it's sometimes good to look at the graph itself to give us an idea of where the zeros are going to be showing up. So here we see that both of the zeros are positive. It looks like it could be 2 and 6. If I go second graph, well, when x is 2 and x is 6, the y values are both 0. So that means x equals 2 and x equals 6 are the solutions for this here. So if we want to write that, we could write it as x equals 2 comma 6. That will work as well. So we don't have to write x equals twice, but this will work just as well. Any questions on this here? We like this method, yes? Solving by graphing. Well, we're going to look at 2 more, and then we'll move on. Here we have 1/2 x squared equals 6x minus 20. Well, what's the first thing we'll need to do? We need this equal to 0. Now, since we know that we're going to graph it, we're going to plug it into the graphing calculator. We can subtract 1/2 squared from both sides because we need it equal to 0. It's 1/2 x squared minus 1/2 x squared. These will both cancel, telling me that I have 0 on the left-hand side. Now, the 1/2 x squared is not a like term with 6x or 20, so we can't combine anything. We can just put it out front, negative 1/2 x squared plus 6x minus 20. And again, we can graph it. We can plug it into the graphing calculator. So if we plug it into the graphing calculator, we'll hit y equals. We can clear this out. Now to plug in a fraction, we can go alpha y equals enter. And we can say negative 1 over 2 x squared plus 6x minus 20. We're able to get it typed in. And if we hit graph, and this function crosses where? Does it cross the x-axis? So if it doesn't cross the x-axis anywhere at all, it means what our solution is. No real solution. It's going to be no real solution. So does that mean there's not a solution at all? Well, no, it's just our solution is not real. We're not talking about real numbers. We're talking about imaginary numbers. And there actually is such thing as imaginary numbers. And we're actually covered this week. We'll cover what they are. So there is a solution to this function. It's just not real numbers. But there is a solution to it. So if it doesn't cross the x-axis, well, we can't solve it by graphing. Because by graphing is where it crosses the x-axis. So graphing doesn't work every single time, but let's try this one here. 4x squared minus 12x plus 9. So if we want to type this in, we'll go y equals 4x squared minus 12x plus 9. We type that and hit enter. This one does cross the x-axis at where? Well, we can say it does look like it crosses, yes? Well, if we look at the table, do we have a y value of 0 showing up on the table? No, so we'd have to possibly manipulate the table to figure it out. Now we do know for a quadratic function that the distance from the vertex of the axis of symmetry will always be equal to the two corresponding points on the function. Do we notice that symmetry here with the y values? Well, we have 1 and 1, 9 and 9. So most likely it'll be between these 2 points. Because it actually works out that x is 1.5. But as we can see here with graphing, if it is decimal numbers, here it worked out nicely. But there might be cases where it does still cross the x-axis, but because it does not intersect it at whole numbers, we may or may not be able to find it by graphing. So graphing, using graphing to find the solutions to a quadratic function really work well if the solutions are whole numbers. Because if they are whole numbers, it'll give it to us directly and we're done. But if it's fractional or decimal, it doesn't work as well. If it's irrational, it won't work as well. Or if it is complex or imaginary, it doesn't cross the x-axis, it won't work as well. Now, any questions on graphing before we look at the next one? Now, the next method we're looking at is called the square root method. I will tell you right out, this method does not work every time. The main way that we're going to use the square root method is if we have one or two setups. The first is if we only have x squared, if there's no x term. Because if we look at this here, we do have an x squared. Do we have an x term? No, we can use the square root method. The other setup, and we'll look at those two when we'll get back to this one here probably tomorrow, is this one here, where I have a set of parentheses squared and no other variable outside the parentheses. Because if we look at this here, x plus 3 is inside parentheses squared. Are there any variables anywhere else? Well, no. So the square root method works best for these two cases. And really what the square root method is saying if we have it in one of these two setups, so here, we do have x squared by itself and no other variable in the equation, yes? To use the square root method is we would get x squared by itself. So here we have 4x squared minus 31 is equal to 49. How can I get the x squared by itself? We can add 31 to both sides. And if we add 31 to both sides, well, negative 31 plus 31 is 0. So we'd have 4x squared equals 80. Is x squared completely by itself? No, we still have the 4, so we would divide both sides by 4. Which will tell us that x squared is equal to 20. So the first part of the square root method is, well, do we have kind of x squared by itself, or do we have it inside of a set of parentheses squared and kind of no variable anywhere else? Well, here we had the x squared, we didn't have an x, so we got it by itself. Does anybody have a guess at what the next step would be? Square root both sides, because, well, the method that we're using is called the what? The square root method. If they call it the square root method, we're going to have to use square roots at some point. Because the last step is going to be to square root both sides. Now, what is the square root of x squared? X equals. Anytime we take the square root of both sides, we have to add the plus or minus, because we're trying to find the value of x. Because if that value is positive, well, a positive times a positive is still positive. A negative times a negative is positive. So whatever this number is, it could be positive or negative. Now we have to take the square root of 20. What is the square root of 20? Yes, it's a non-repeating, non-terminating decimal. It's an irrational number. Because if we look at 20, it's factors, because again, whenever we take the square root, we're looking for a number times its self. Now, 1 times, well, the square root of 1 is 1. Square root of 4 is 2. 2 times 2 is 4. Square root of 9 is 3. Square root of 16 is 4. 4 squared, 16. 5 squared is 25, or the square root of 25 is 5. Well, does 20 hit either one of those? No, but it's between 16 and 25, or 4 and 5 is how we get that. But if we look at the factors of 20, well, 4 times 5 is 20, yes? Can I take the square root of 4? Square root of 4 is 2, square root of 5. Now, the yellow calculator is the TI-30XS. the ones that we have here, we'll do radicals. It will take the square root of 20 and tell you that it's 4 square root of 5. Or 2 square root of 5, sorry, not 4 square root of 5. And it'll tell you just outright that's what it is. It will simplify radicals. The graphing calculator will, you can get it to simplify radicals, but it requires actually graphing the two functions or graphing two functions and seeing where they meet and their intercepts and a whole lot of extra steps. So if we wanted to really simplify a radical, I would just use the yellow calculators or the white ones, the TI-30XS, to do that. That's also why it's kind of nice to have them on the ACT test, because if you're trying to simplify a radical, it'll do it for us. But these here would be the solutions. And as we saw here, 2 square root of 5 is 4.7, or 4 point something. It's a non-repeating, non-terminating decimal. So would that be easily found by graphing? Well, no, it's not a whole number. Let's look at this one here. Is x squared by itself, or is there any other variable besides x squared? No. So that means we can use the square root method. So what can we do first? Add 9 to both sides, which will tell us that 3x squared is equal to and this will tell us that x squared is equal to x is equal to plus or minus 1. What two numbers multiply together to give me 3? There's only one set. 3 and 1, yes. 3 is prime. Prime numbers never simplify. So it's just going to be square root of 3. Because we could plug it in the yellow calculator and it'll just throw back square root of 3. Because it doesn't simplify. There's no way to simplify it. Questions on any of this here so far? Let's look at the next one. Solve each equation by using the square root method. So here, since we do have a set of parentheses squared, and there's no x outside of it, well, if I take the square root of that set of parentheses squared, I would just be left with whatever's inside the parentheses, because the square root and that square would cancel. And since I don't have x anywhere else, we can go on and solve it by the square root method. For a set of parentheses squared, there still cannot be a variable anywhere else. The variables have to stay within inside the parentheses. Because if I had equals 5x on the other side, I would actually have to use the distributive property and actually factor out the x plus 3 squared. But we can go on and work this out. So what's the first thing that we can do to get those parentheses by themselves? We need to get rid of this 2/5. Now we can multiply it by 5/2, or we could divide it by 2/5. It's going to be a little bit easier to multiply by 5/2 than it is to divide by 2/5. And not so much for simplifying the 5/2 and 2/5, but when we divide 5 by 2/5, we'll have to do some more calculations there. So when we multiply by the reciprocal, we multiply straight across, it'd be 5 and 2, 2 and 5. Well, 5 times 2 is going to be the same as 2 times 5. So really it's dividing by itself. So that just simplifies to 1. This is gone, just leaving us with x plus 3 squared equals, well, the 5, we can realistically think of it as 5 over 1. So the 5 and 5 would multiply together to give me 25 over 2. Any questions on any of this here? So is the set of parentheses by itself? Well, yeah, there's nothing else with it, correct? So if I take the square root of both sides, well, here the square root and square will cancel out because the square root of a number being squared simplifies, leaving us with x plus 3 is equal to plus or minus now again, we could type this into the calculator. The graphing calculator will give us an irrational number, a non-repeating, non-terminating decimal number. Now, if we type this into the calculator, it should give us 5 square root of 2 over 2. Square root 25 over 2. We might have to type it in instead of just 25 over 2 is the square root of 25 over the square root of 2. And that's what you'll have to do for this here is break it up into the 2. And the graphing, or the TI-30XS will tell you that the square root of 25 halves is 5 square root of 2 over 2, simplified down. Or we could give it as the decimal answer. Now there's one last step. Do we have x by itself? Well, no. We have x plus 3 is equal to this. So the last thing we need to do to get x by itself is to subtract 3 from both sides. Now once we subtract 3 or add 3, once we get the plus or minus in, the number that we add or subtract will always go in front. Will always go in front. This is just a standard way to do this. It's not that there's a set rule for it. We just always put the number that we add or subtract in front of it. Now, if we actually turn this into a decimal, we would actually get 0.5355 or seconds for minus 6 or negative 6.5355. Now, if you're curious where those numbers are coming from, it's really coming from the fact that we're taking negative 3 plus 5 square root of 2 over 2, which would be our negative 0.5355, or taking negative 3 minus 5 square root of 2 over 2, which would be our negative 6.5355. And just having the calculator convert our 5 square root of 2 over 2 into a decimal. Because if we convert it over into a decimal, we would have these two answers here. But we can also leave it in radical form, and that would work just as well. Any questions over this here? All right.